Hi, Kraken. How are you?
I'm doing pretty good. It is quite early in the
It
morning.
is. It is very early. Yes. So, who are you? What do you
Um,
study?
all right, so I am known on the internet as Kraken. Um, in real life, I'm known as Candace. I am a biomedical engineering PhD candidate in the US, um, and I am being interviewed today.
So you say biomedical engineering. What exactly is that?
So, biomedical engineering is kind of the intersection of biology and medicine and applying engineering principles to develop solutions. That's about the most broad explanation of what biomedical engineers do. Um, but I also find that it's the most encompassing explanation of what we do.
So, to someone who doesn't know, like, really what biomedical engineering is, could you give like a good example of like a day in the life of how someone in your field, normally wakes up, gets to the lab, and goes through, what they do?
Yeah, absolutely. So it really differs depending on what aspect of biomedical engineering you're part of. Since it's a very large and broad field. So a very good example of a area where biomedical engineers work is in medical devices. And so somebody in medical devices, if they're maybe doing maybe they're a field engineer and so they go out into hospitals to provide support for surgeons or hospital staff on operating medical devices. But then there's also the more research laboratory side, which I am in, obviously, since I'm doing my PhD. So my day is never the same. Part of that is because I am doing my PhD, so I am doing a lot of research. And so my day is kind of structured where I guess my time is kind of structured around experiments and especially more time sensitive experiments that deal with living organisms. So, mice, I have cells as well. Um, and my day kind of revolves around my work involving living organisms like my mice and my cells, and then I do everything around it. So I typically spend maybe 40 hours a week in the lab. Um, I do a lot of various things. I run a lot of assays. I currently am doing a mouse study. Sometimes I have cells. I currently do not have cells going, but also I do quite a bit of data analysis as well on the data that I collect from my mice and my cells, from the assays that I perform, lit review as well, always staying on top of current research. And that is kind of how my day goes. I spend a lot of time in the lab, and then I'll spend some time on the computer just trying to make some sense of it all.
Sounds like a very busy day.
It is. It is also somewhat flexible in the sense that I don't always have cell and mouse work to do. So, a good example would be today. I actually, the only task that I have to do right now is we just got some mice and I need to acclimate them to being singly housed because it's part of our project. And so, all I'll be doing today is going in, putting them in separate cages, and that's about it for the lab work that I need to do today. Um, if I wanted to be a bit more productive, I would run a couple of assays, but I also haven't really had any days off for a pretty long time, so I might just take today off.
That sounds like a good idea to me.
Yes, if like anybody who's listening or reading from Biocord, you all know that I have had very little time off while I've been doing this mouse study. Um, Living organisms make things a lot less flexible, would be the biggest drawback I think about being in biomedical engineering rather than like maybe chemical engineering.
What made you choose biomedical engineering?
That is a very good question, and there's a short answer and a long answer. So I've always been very fascinated by medicine. Um, and I found out very quickly that it wasn't necessarily medicine that I was very interested in, but it was developing solutions for it, whether it be through medical devices, through developing novel methods for surgeries. And so I think that was more so what entranced me. And to give a bit more background, I was a competitive gymnast for many, many years. When I was younger, I retired when I was 18 because I wanted to focus on school before I went to college. And with gymnastics, it can be, sports in general can be quite, they can really mess up your joints. And so I've had osteoarthritis since the 5th grade. And as a little 5th grader, I didn't know very much, but I think my family is very science slash academically oriented. And so I tried to look up, what are the current methods for recovering from osteoarthritis, or like what do people do to solve the issue of having osteoarthritis. And I found out, to my horrifying dismay, that at the time, and remember this is about 2005 to 2010, that what they do is they stick a giant needle in your knees and they puncture the bone to allow like bone marrow and vascularization to go into your cartilage, because cartilage is not vascularized. You don't have any vessels in there. And so that's also part of the reason why they don't really regenerate, is there's no nutrients going into your cartilage. And so they stick this giant needle in your knee. They puncture the bone so that it's like forcibly putting blood into your cartilage. And that is that is what they do if you have osteoarthritis and you don't want to just like endure it. And that horrified me. And I was like, you know what? There has got to be a better way to do this. Maybe I will be the person to figure this out. And that is how I became a biomedical engineer.
Sounds like a direct pathway. I mean, it's something that, holds dear to you,
Oh yes,
especially.
I'm very invested in this field since, my knees are kind of screwed up quite a bit.
Mhm.
But I also found later on, like, I have other interests as well other than cartilage regeneration, which I don't actually work in right now. Because I was an athlete, I'm also very interested in muscle regeneration, which I do currently work in. And so as I started going into biomedical engineering a bit more, I started to find more things that I was interested in. And I'm like not interested in just one thing, but there are a lot of different areas that I'm interested in. And so that was kind of my signal that this was probably the right field for me. And it wasn't just like, oh, I'm only interested in one aspect. And if I don't do this one aspect, then no, this is absolutely terrible. No, I like actually genuinely very much enjoy a lot of aspects of my field. And if I had to do like a career change and completely change um, directions, and I'm no longer doing muscle regeneration, and I'm doing some other aspect of biomedical engineering, I wouldn't be too upset because I also would probably find it interesting as well.
Remind me again, you said like one thing you've always been interested in is medicine, right?
Yes.
So, with a biomedical engineer and something like an MD, why would you choose, you know,
Maybe what's the
yeah,
difference between them and why I chose engineering rather than medicine?
yeah, thank you.
So I also thought about that. This is now I'm like moving more into my high school ages. Because obviously surgeons and doctors also develop solutions. I did a clinical internship, was a veterinary clinic, But I found out very quickly that I was not interested in treating people. Like, I just was not interested in the front facing aspects of medicine.
Hmm.
And I think for me, if I did an MD instead of like doing engineering, I think that I still would have been relatively like successful. But I like to do stuff with my hands. I like to design things. That is not usually the bulk of what medical doctors do. So I think that was the biggest difference, is that I wanted to design and develop solutions, and that be the bulk of what I do. And not to say that aren't any doctors that do that. I just felt like doing biomedical engineering was a much more direct path to what I really wanted to do. Like, I was always more intrigued with the instruments and the equipment that doctors use rather than using the equipment themselves. Like, hypodermic needles is one of the pieces of medicine, like medical equipment, that really blew me away, because the amount of engineering that goes into a hypodermic needle is actually quite immense, because you can't extrude metal in a way that is so small and so precise. And even just getting that point on the needle requires a lot of engineering and knowing about material properties. Um, and it also has a very specific use. And so that was kind of why I didn't go through with medicine, because I was more interested in the stuff rather than the
Hmm.
medicine itself.
So I guess as you're growing up, you're getting into high school, you have your friend group and everything. Did a lot of your friends growing up share kind of that interest and follow the same route, or did you kind of, pave your own path, or and kind of make yourself independent of a lot of what your friends?
None of my friends went into the field that I did. I went to a very artsy school. Like, I went to an international school in Hong Kong,
Hmm.
and we were very well known for having really excellent results on like AP exams. But the ones in particular that we did really, really well in was AP art. And so
Okay.
I was actually an art student for quite a few years, where I was like kind of thinking at the back of my mind, like, oh, maybe I could go out for art school, which obviously didn't happen. My mother said no. And I was like, wasn't too upset about it, because I was like, engineering is so much cooler anyway. But most of my friends actually went into either art or like criminology or psychology. And so
Mm.
nobody went into the direction that I did. But there were people in my class who ended up doing like biology or like biochem as degrees, and then they went to medical school, but nobody went into biomedical engineering.
So going up in a art school, do you find that a lot of what you learned about like arts and stuff like that is helping you in this field?
Oh, absolutely. So I am continually finding that creativity is so important in engineering, in science, and especially if you're trying to develop something new. Like, you, as a PhD student, your whole goal with a PhD is to create this little new dent of knowledge in like the whole circle of knowledge that is existing in the world. And finding your way to making that new dent in knowledge is requires an immense amount of creativity. And so like I am an engineer, but I can also appreciate the fact that I have had a lot of artistic training. And so being able to think in that aspect, and it's not just like, all right, here are the criteria and this is what happens, but being able to think outside of the box has really helped me immensely as an engineer, but also as a scientist. And I think that is ultimately what has made me quite successful in my PhD candidacy career, is being able to think outside the box. And it is something that people can learn, but I think it is something that I've picked up relatively quickly. Another very good example of where creativity is absolutely needed is my undergraduate program for biomedical engineering was very medical device focused. And so a lot of kids wanted to go into R&D because that is usually the most popular thing that people want to do if they go into medical devices. They want to research and develop medical devices. And that is another area where creativity is absolutely required and um, is a boon to have. Is when you are trying to develop and create something new. So yeah, I really appreciate having my artistic talents and like background. It wasn't really an art school. It's just like a lot of people ended up doing art.
I gotcha. So I guess moving forward, you started undergrad, you were going through that. What is your, I guess, family think about this? Like, is there a lot of knowledge in this, or do you find sometimes that communicating science to your family is sometimes hard with how, I guess, complex and how even fairly new in the world history that this field is?
So my family has always been very supportive. I mentioned earlier, my mom said no to art school, but she also said no to music school. She also said no to biology. But she was perfectly fine with biomedical engineering. I think the word engineering was what was like, aha, this is a technical degree. You can probably find a job in it. And so she was perfectly fine with biomedical engineering. Um, my brother is also an engineer. My mom is not an engineer. She did her doctorate in accounting, very completely different field. Um, I am not entirely sure whether my mother knows what I do exactly. Um, my brother has a much better understanding of what I do, but he also likes to lie to people to be funny about what I do. He likes to make what I do seem more horrifying than it really is. It's just like a friendly sibling banter. But my family, my immediate family at least, are very supportive and mostly understand what I do and think it's very cool. It isn't, I have found that it is easier to explain the longer that I'm doing it. And I think part of that is just learning how to communicate science effectively
Mhm.
rather than it being such a niche field that I can't explain it. I think that is, it's just, science communication is just something that should be learned. And I am finding that I am having an easier time explaining what I do the longer that I do it. I've learned what words to use and what words not to use. My mother somewhat knows what I do. When I first told her what I was doing, she had absolutely zero idea of what I was doing. Um, Now that I've just finished my third year of my PhD, she kind of has a better idea of what I do, but I also don't think she cares too much in what I do, just that she's very proud of me and that it is cool science things. And then my
So
and then my brother likes to lie about what I do. He knows what I do. He just wants to be funny.
it's nice little sibling, banter.
Oh,
And they're
absolutely. I have had his friends. Like I will have dinner with his and him and his friends. Like his friends that like live in California after graduating from undergrad, they like move away. They've come back from California and we've had dinner and one of them was like, "All right, what do you actually do? Do you actually break your mice's legs?" I'm like, "No, no, I don't do that." Has Brian been telling you that? Because that is absolutely not what I do. So it's kind of that thing where it's like, ugh.
but for someone who is kind of paving their own path and their family hasn't branched out into college, but they're finding themselves trying to explain um, you know, engineering or biomedical engineering to their family and to their friends who might not know, a single thing aside from what they read on like Facebook or see on the news or something. How would you, any advice would you give them for like communicating effectively for that?
I would, I need to think about this for a little bit. But
Mm.
first of all, It is not your obligation. I would tell that person that it is not their obligation to make somebody understand. Um, because the reality of it is that there are some people who just don't care what you do and don't care to truly understand what you do, and sometimes less words is easier. Um, so I used to have like this whole spiel about what I do, and now I just tell them that I make muscles grow big. Um, just putting it in a very easy way for other people to understand is can be immensely helpful, but also recognizing that it's not your obligation to force somebody to understand. Whether or not they understand is, or whether or not they try to understand is, can be the biggest hurdle. Um, and I kind of learned about this the hard way. Um, but in terms of paving your own path, I think finding mentors who are uh, who always have your best interests in heart, but also who have the experience to give you unbiased and supportive advice has been immensely helpful. Because you know, you can have multiple mentors for many different things. Like my mom is definitely a mentor to me because she's been in academia for a really long time. At the same time, she isn't in science though, and she's also in academia in on a different continent. And so the politics of that and how like admissions and like faculty and like even like PhD interviews go are completely different. And so I'm not necessarily going to go to my mom about that sort of thing. Um, my brother is also a mentor in the sense that, you know, he has a very solid career, um, but he's not in academia and he's not in biomed. He's electrical engineering. And so he is a mentor to me in some ways, but in a very, he has a much better bird's eye view. He's very good at giving very unbiased viewpoints if I like give him a situation, but I'm not going to go to him about academia. So it's fine that you have mentors and you seek advice from multiple different people, um, but making sure that you know you are asking the right people and you're asking them the right questions. Also, talk to people in your field or the field that you intend to go into, because um, I think it can be really difficult having family or like the majority of your family not in the same field, and that being very difficult. I can recognize that there can be a lot of pushback from it. And so finding people that are encouraging and understanding what they've gone through and being able to relate that to you is very important.
Okay. So I guess shifting gears to more you now, in terms of your workday, like what's a typical problem that you commonly face in the lab or in some form of your field?
I have to troubleshoot a lot, and that's a very engineering thing that I have to do. But I think it's also very common in like just science in general where something did not work and now you need to figure out, maybe you figure out why, but you have to figure out how to make it work.
Mhm.
Um, so for me, I have pioneered quite a few different protocols as well as techniques in our lab. And so I would spend months just trying to like practice and just trying to figure out what the ins and outs are of it are, so that when I do bring it, so when the time comes to where I actually have to perform it, I don't get any issues. And so that could mean that I am doing a lot of dissections Or that could also mean that I'm just like running Western blots end on end. Um, that is a pretty typical problem that I face. It's just like constant troubleshooting. There is always troubleshooting to be had. Um, like if I'm just trying to add a new technique into the lab, I'll have to troubleshoot it. I'll have to optimize it. And being an engineer, I can't not optimize something to where it works well enough for our purposes. And so that's kind of something that I do a lot in my lab. Like currently, I'm trying to troubleshoot IHC, immunohistochemistry, for my lab for muscle sections. We've done this a lot for liver, but we don't actually have a protocol for muscle, which stains very, very differently from more fatty tissues like liver and fat. We usually do fat in our lab. But also, my sections are cryosectioned, and so whereas our fat tissue has always been paraffin embedded, and so even that difference can completely affect the protocol. And so currently, I'm trying to develop a protocol that works for our lab so that we can do immunohistochemistry for muscle sections for freshly frozen, flash frozen muscle sections. That's a pretty typical problem that I face. Or sometimes your cells just die and you don't know why. That's a fairly common thing that happens. Western blots doing strange hand wavy magic things is also another common problem. Um, yeah, I would say that's a pretty typical problem is just like things not working the way you want them to, or just trying to optimize protocols and develop protocols.
So with those problems, do they typically get smoothed out pretty easily? The more times you encounter something like that, or does it vary from problem to problem?
It definitely varies problem to problem. Like, I am imagining immunohistochemistry to be less of an issue because we do have an existing protocol. Um, but there are things that do feel like I'm banging my head against the wall. So another problem that I can think of is this is not directly my project. This is a project that I am finishing up for somebody else, but I'm trying to do so the task that I was given was to show a Western blot of a very specific protein going down as a dose response. Um, then we found out, and so yeah, I like conducted this several times, but the result kept on changing, and I found out that it's because that the housekeeping gene also gets affected by the dose response. And so I spent quite a few months just trying different housekeeping genes, then realizing that I can't use housekeeping genes. All of it gets affected by this dose response. And so I'm having to like do Ponceau staining and figuring out how to do Ponceau staining. And then we got a new imager, and like figuring out how to use the imager because it was like doing blurry things. It was kind of a mess. And so currently, that project is on hold because I've got more important projects to do. Um, so not everything gets smoothed out easily. I think a pro of being in biomedical engineering is that my field tends to be a lot more collaborative. Um, like everybody in my lab works on each other's projects. We all have our own project that is very unique and very different from each other's, but we all help each other on each other's projects. Like there is absolutely no way that I can harvest 5 mice in 3 hours without the help of at least two people. That just doesn't happen. And so I think that is a pro where I do have multiple people helping me, and I'm also helping multiple other people, and we also get to learn from each other. And so we can also troubleshoot together. Um, but it really does depend on what problem it is and how smoothly it gets solved.
So I guess moving towards like your field as a whole, what's the current dynamic in your field?
I think biomedical engineering being one of the more recent, um, like biomedical engineering as a major isn't very old. Like it isn't like electrical engineering or mechanical engineering where they've been around forever. Biomedical engineering is actually fairly recent, in the grand scheme of, like, relative to other engineering disciplines. And because it is so new, I think the field is a lot more, um, it's more forgiving when it comes to support and mental health. Um, it's a lot less cutthroat than some of the other engineering disciplines. And I'm just thinking about my time during undergrad and at the program where I'm currently at, is that it's a lot more supportive. We also do require a lot more group work because the reality of my field is that it is very collaborative. And I touched on this earlier, but it is almost impossible to pull through an entire project by yourself without any sort of collaboration with your colleagues and your peers. Um, like every single program that I can think of forces almost a group, almost like at least one group project in every single course. Um, so I think that it is a very supportive field, and there is a lot more representation in biomedical engineering just being a newer discipline. But at the same time, I recognize that uh, some of the more toxic aspects of engineering and academia are still prevalent in biomedical engineering. And I think that is an issue, but it's not unique to biomed. But
So,
I will say that there are a lot more women in biomedical engineering than you would typically see in, like, say, electrical engineering. Like, at Georgia Tech, the ratio for us was 50-50, which was not the case for any other engineering major. So there is a good amount of representation. It could still be better, but it is a step in the right direction.
so I guess moving forward in your career, you're getting in your, not to, throw the age stuff, but like as you get in your 30s and 40s in your field, what is something that you hope to see more of?
Oh boy, that is a difficult question. Um, do you mean like in my field or for me personally?
uh, I guess for this question in your field and engineering and biomedical engineering as a whole.
I think better representation and better representation always. Because if you look at, like, say, like chairs of engineering schools, they're almost always older white men. I know Purdue just academia in general needs better representation. And in my field, I think it's not as bad as some other fields, but it's still blatantly skewed. And so that would be the first thing that I would like to see more of. I think another thing that I would like to see more of is a lot of biomedical engineering programs currently are very geared towards medical school, which I think is kind of very irritating because I don't like that a lot of people view my major as a stepping stone from medical school, because what we do is very, very different from what medical doctors do. Um, so I would like to see more programs being more independent and giving themselves a name for being engineering rather than pre med. Um, I think that I would also like to see I would like to see biomedical engineers make a bigger name for ourselves. A lot of companies still don't know what we do, and that has made it really difficult for undergraduates to market themselves, because even undergrads don't really know how to explain what we do as a way to, like, in an effective way to interview and to look for positions. And so that is something else I would like to see from my field.
All right. Yeah, something for, especially for a field that, it always takes a little bit of time, it seems like, to
Oh,
iron out the kinks.
absolutely. Absolutely. And like the program where I'm currently at, we're like changing our curriculum every few years because we're realizing things that work and what things that don't work. Like it's
Hmm.
a fairly new program. And so like the undergraduate program is. And so there are always things to change, but it also like it confuses the students, and I think like a lot of students just don't know how to market themselves. And that's so much true in almost every discipline, but I think because biomeds are a newer field and there's a lot of like vague, hand wavy descriptions of what we do, is that people misunderstand what we do and don't know how to utilize our skills.
So I guess these two questions kind of tie in together, but for young women going into the field and wanting to think, I want to do biomedical engineering. What is some advice that you wish you could have given yourself at, 16, 17, 18 years old, that you would give the young women wanting to go into this field?
Talk to some engineers, like actually talk to some female engineers, biomedical engineers, but yeah, absolutely talk to scientists and engineers that you know, or just like reach out through like Twitter or email, join a Discord server. But getting like an actual view of what we do, I think would have been immensely helpful for me. And also, like, advice that I would absolutely give myself is to chill out. I was so focused on trying to prove myself. Engineering is hard for a woman because it is so male oriented. I feel like a lot of women in engineering constantly feel the need to prove ourselves. And it's not just in engineering and science in general. I think that women um, feel like a very underlying chronic need to prove ourselves. Um, and I would have told myself to like chill out because, I know now that I am a fantastic engineer. I'm very successful in my PhD career. Um, and I don't need no man to tell me that I am an engineer. I know myself that I'm an engineer. And so I would have absolutely told myself, younger me, to chill out a little bit and recognize that I am a great engineer and I can become a really good engineer. And I don't need to seek approval or recognition from other people um, to be an engineer. There's so much salt in that. I am very salty about my younger years. Um, just like various things that people have told me, various things that people have said about me being a female engineer that I'm just very salty about. And so I think every woman in engineering has experiences like that. Yeah, it's difficult, and so um, it's hard.
So is there any closing comments you have for this?
Do I have any closing comments? Don't be afraid to craft yourself into the scientist or engineer that you are. Um, I am very different from my peers, especially like my peers that, like my fellow Asian engineering peers. I am very different from them. And I'm like pretty proud to say that I am. And it's not that going with the flow is bad, but I just feel happier um, just being different and not going with what is expected of me. I don't know if that makes sense.
Almost like being you.
Yeah, being me. Like, I am absolutely the type of person who will put smiley faces and like emojis if I am sending emails to the chair of the department. That is me. And I'm sure the professors have things to say about me, but you know what? At the end of the day, I'm never going to find out what they think about me, and I'm enjoying myself. And I still know that I'm a fantastic and very productive engineer. So, oh man, my cubicle is plastered with pictures of kiwi, and I am very unapologetically like proud of that. Like people walk into our office that has like 22 people, they're like, ah, this is Candace's desk. Absolutely, it is my desk. There is kiwi all over it.
Something I was always told, as I got older, and don't ever lose who you are.
Absolutely, but you could also like develop yourself in different ways. But like even me, I have changed in so many ways since starting graduate school. Like working on yourself is just such a dynamic process. But becoming an engineer is such a dynamic process. And so, um, yeah, like don't be afraid to lose yourself, but also don't be afraid of like changes to your personality that just happen because you're growing. Like 25-year-old me is not the same person as 28-year-old me. Yeah, don't be upset or like afraid of those changes because it's so much effort to try to force yourself into a very specific box that you set for yourself.
All
Something that
right.
I really want to do in the future is I have all these stickers. I just hoard them. I have a sticker subscription. And so, like, in the future, if I ever do become a professor, I just want to, like, give the kids with, like, the good grades, I'll just put a little sticker on them. That thought pleases me.
There's always something nice about seeing that A with a sticker on it.
Yeah, it's like a little like, oh, this is so good. Like even now I'll put like little happy faces when I'm grading papers. I'll underline something and be like, I like this sentence, happy face. And it just like gives me joy. And I like to think that like cuz I like seeing that. And so I like to think that my students enjoy seeing that. Makes engineering a little bit less painful if they see like, oh, my TA put a little happy face on my exam.
All right. Well, it's about all I got. So thank you
Absolutely. This was my
for doing
pleasure.
this.